So far, we applied sparsity through the ReLU function. Now, let's explore another way to reveal sparsity, in particular through temporal differentiation. So, as a reminder, we looked on this kind of temporal trace. Basically, we took their pixel value and explored how it changed over the frames to receive this temporal signal. So you see here how the pixel values are changing over time. And now we are interested in comparing the pixel values across different time points. So let's define this operator, where we basically take the pixel value at frame number t and subtract the pixel value in frame t minus 1, basically taking two consecutive frames and comparing them. So how do you think that the temporal difference of such a natural signal will look like? Basically, this is your goal now. You need to define this temporal differentiation operator, and then you can explore the result. So let's see how the signal will look like. After taking the differentiation, we get this temporal trace, where you can see that we have a lot of zero values. Basically, we received a very sparse signal that reflects the smooth and slow changes of our original natural temporal trace. Now, why do you think that it happened? Please think with your TA and with your group. Now, we can explore how this temporal differentiation affected the kurtosis. As a reminder, the kurtosis is a metric to measure how sparse a signal is. So if the kurtosis is high, it means that the signal is sparser. When we compare the signals before and after the differentiation, we see that after the differentiation, the kurtosis significantly increased. Also, we can explore the distribution of the values, where before the differentiation we got very high values, while after we got mostly zeros, reflecting the sparsity. So far, we compared two consecutive frames. But there are some challenges with comparing just two frames, because we don't consider longer scales. Maybe the changes in the video occur on a longer scale. So for this, it's worth checking also longer scales, comparing a frame t to tau previous frames, t minus tau. So this is one possibility, but it's still, there are some issues with this. There are some disadvantages. So if we compare the one-step filter to the multi-step filter, there are some problems with both. In the multi-step filter in particular, the issue is that we don't consider it as intermediate values, and we might miss some important information. So for this, we would like to use kind of a wiser filter, which is the box filter, where we compare the pixel value in the relevant frame to multiple other frames, instead of taking only two frames and comparing between them. So now, how might a box filter influence the sparsity patterns in the observed data? Now, your goal is to define this box filter and apply it to our signal. This is the signal, this is the filter function, and this is the result after applying the box filter to the signal. And you can see that we received much sparser signal compared to the original, while we maintained high differences between some frames where there was a high difference between the pixel value.